The broadcast is now starting. All attendees are in listen-only mode.
Well, hi there, and welcome from Studio 27 in Sacramento, California, and to our other speakers in Northbrook, Illinois, to today's very timely webinar, Standards for Driving Innovation for Electric Vehicle Infrastructure Equipment Providers, sponsored by the Underwriters Laboratory Smart Grid Integration Initiative and hosted by WebAttract, your end-to-end solution provider for informational webinars. Hi, I'm Mike Agron. I'm the executive webinar producer with WebAttract, and I'll be your moderator and one of your hosts for today's session. In just a moment, I'll be introducing our featured speakers who are not only seasoned experts in today's topic, but very excited to speak with you. Now, most of us probably are familiar with Underwriters Laboratory, or UL, and they're best known as an independent, not-for-profit safety testing and certification organization, actually founded back in 1894. And what they do is they continue to leverage their reputation as a global leader in product safety standard development through their many, many divisions, including today's speakers from the Smart Grid Integration Unit. So in just a moment, I am going to be introducing our featured speakers, Chris Pauly, the Smart Grid Integration Manager, and Joseph Bablow, the electric vehicle technical expert, and they're going to provide their insights, best practices, and lessons learned around today's topics, which is standards for driving innovation for electric vehicle infrastructure equipment providers. But first, we'd like to tell you a little bit about who some of your other colleagues are that joined for today's webinar, and also let you know that we are going to have time at the end of the webinar to take a lot of your questions. So we've invited professionals that represent a cross-section of automotive and consumer electronics manufacturers, industrial infrastructure equipment suppliers, folks from utilities and regulatory inspectors. And these are people who are leading the charge so that the mass market adoption of electric vehicles can become a reality. And we're sure that's why you're here. And regardless of your industry affiliation or role, we're absolutely confident that you're going to find value in today's webinar. And actually, due to the high degree of interest in today's topic, while we plan to complete the formal discussion and take to your questions by the top of the hour, if you would like to stay on and ask Chris and Joe more questions, we're going to keep the webinar open for an extended Ask the Experts panel for about another 15 minutes. So I'll make that announcement at the end. And we're going to start the webinar with Chris Pauly. And what Chris is going to do is provide us an overview of some of the industry trends focusing on business opportunities around the development of electric vehicles, EV charging stations, EV quick chargers, and cables. Then after Chris is done, we're going to hear from Joseph Bablow, and he's UL's EV technical expert, and he's going to talk about on what you need to know around some critical standards for getting your innovative technology to market more quickly, how you can use these standards to reduce your risks by working with UL early in your product development, and how you can attain global market access to meet your certification needs. So all that's coming up. And then at the conclusion of Chris and Joe's portion, they are going to be taking your questions. So we'll get to that. Well, let me tell you a little bit about Chris. He's got quite an interesting background. He's been with UL for more than 4 years, and he currently leads UL Smart Grid Integration Initiatives, which includes electric vehicles and smart meters. Before his current role, Chris was the Strategic Global Pricing Manager for UL's industrial sector. Now, he holds a Bachelor's of Arts from the University of Iowa, a Juris Doctorate from DePaul, and a master's degree in business administration from Northwestern University's Kellogg School of Management. Chris, absolutely delighted to have you join us, and welcome to the webinar. And tell us a little bit about what you're going to be covering today.
Thank you, Mike, and thank you very much for that nice introduction. And thank you to all who are participating and listening in on our webinar today. Today we're going to be talking a little bit about some of the market trends in electric vehicles and related infrastructure equipment, some of the technology advancements that we're starting to see coming out of the marketplace, market opportunities, where we are committed from a UL standpoint to this emerging business. Joe Bablow will talk about our standards that are impacting these products. And finally, we'll be starting to look at how can we work best with our customers, and how can our customers start to work with UL. Next, I'd like to give a kind of a brief background on UL. As Mike indicated, UL has been around for over 115 years, and we're dedicated to the development and publishing of safety standards, as well as providing education and training programs, in addition to our core safety mission and certification and testing businesses. UL is truly a global company where we have offices around the world. Although we are considered a U.S.-based company, we have facilities and capabilities that stretch to almost all the continents around the world, where we can go ahead and give our customers the global reach that they need for their true global market access. The advent of electric vehicles and related infrastructure equipment is a global phenomenon and will require a certifier with global reach and global testing capabilities to be able to fulfill your needs. What we're starting to see is that after years of thinking and planning, the next advancement of technology is starting to occur within the automobile and energy industries. The long-term environmental, political, and economic impact of fossil fuels has been well talked about, and there's real momentum behind plug-in hybrid and electric vehicles as a sustainable alternative. Research suggests that plug-in hybrid electric vehicles will be approximately 33% cheaper to operate and can generate somewhere between 30 to 40% lower greenhouse emissions than vehicles currently powered by fossil fuels. As fuel costs continue to rise around the world, and as battery prices fall, and in the short term there continues to be governmental and local support, consumers will start to take a look at plug-in and electric vehicles. In fact, there are some indications that by 2015, as many as 1 million U.S. consumers will choose to drive plug-in and electric vehicles as clean, cost-efficient alternatives to vehicles currently powered by fossil fuels.
Chris, it's Mike. Can you tell our audience how large of a business we can expect to see outside of the U.S.?
Absolutely. So what we're starting to hear is higher penetration rates both within Asia and Europe for a couple of reasons. One, especially in Europe, just higher fuel costs. And coming from some of the Asian countries, we're starting to see large governmental intervention and support, which should increase and spur adoption rates that may even exceed in the U.S. In fact, in some studies we've seen, there may be as many as 12 million plug-in and electric vehicles sold outside the United States by 2020. What's helpful for those on the phone to have is a little bit of background from a technology standpoint for the vehicles themselves. And what we're starting to see is really three types of vehicles coming to the marketplace at the end of 2010 and really starting in 2011. Those would be battery electric vehicles. And those vehicles are defined in many cases as having one energy storage system, with, in this case a battery, no primary means for onboard generating electricity. In this case, the energy is transferred to the vehicle by plugging into an electricity supply or by, in some cases, exchanging the battery for an already charged one. Another example of what we're seeing is plug-in hybrid electric vehicles. These vehicles also have one energy storage system, a battery, which is either recharged from electricity offboard or through some sort of onboard generating device, in some reasons a small internal combustion engine, or, as I mentioned, some sort of electricity supply. And then finally, what's currently we're seeing on the road today are what we're calling hybrid vehicles, and these have two or more energy storage systems, both of which provide propulsion working either together or independently. The internal combustion engine is typically the primary system, with the electric motor used to power the vehicle for short distances and to support the main engine, for example, when the vehicle idles at a stoplight.
You know, we're hearing and seeing a lot of talk about the vehicles themselves. What about companies that are supplying the parts of these vehicles? What are the opportunities for those technology companies?
It's a real interesting mix that we're starting to see, and it's really a confluence of different industries coming together. You're seeing some industries, automotive, of course, industrial equipment manufacturers, high-tech manufacturers, all coming together to produce different technologies, whether it's the new batteries, lithium-ion batteries that we're starting to see on board vehicles, or next generation of motors, onboard chargers, as well as other components such as connectors and cables. It's a fascinating confluence of different technologies, different providers and key players that are both startups as well as Fortune 50, Fortune 5 companies that all see the electric vehicle and related infrastructure and onboard components as a natural growth platform for them going forward. As a demonstration to the areas that UL currently certifies to, this slide shows a breakout between the off-board components and our onboard components. Currently, this discussion today will focus on our off-board side that looks at the different personal protection equipment, electric vehicle charging stations, and related infrastructure equipment. But UL also has an onboard component business that looks at the emerging technology that are going into the vehicle, the so-called electrification of the vehicle, through things such as the batteries, onboard motors and converters, inverters, and onboard chargers as well. So some of the questions that are coming up are what are the current challenges to wider adoption that we're seeing? And some of this happens to be the fact that really the electric vehicle is competing against an already existing technology, which is the internal combustion engine. And so that competition really is relying upon for EVs to really get out there and have a chance to grow with things that are really highly dependent and almost independent of the manufacturers themselves, and that would be areas such as the price of oil, cost of batteries, and as mentioned before, any federal, state, or local stimulus or tax credits that can help spur adoption.
So question then becomes, on the consumer, where do they fit in? How does the consumer fit in regarding the adoption of these vehicles?
Yeah, they're critical. We're really seeing that the consumers are really that critical piece for wider adoption, and we think that education is really the first and foremost for consumers to see the benefits of this new technology and understand what it is and more importantly what it isn't. What we're starting to see is that as consumers look at the introduction of these vehicles, again at the end of this year and beginning of next year, there's a lot of questions that need to be answered, and a lot of things regarding the safety of the vehicle, questions about pricing, and not necessarily the price of the vehicle, but actually pricing in terms of charging the vehicle. For the first time, instead of going to a gas station, consumers will be charging either at home, work environment, or in some sort of other public environment, and having accurate, flexible, and simple pricing schemes and methodologies is critical for them for that adoption rates, as well as aftermarket support, reasonable insurance coverage, which are things that need to be discussed and educated to the consumer base in order to increase overall success and adoption. Other areas such as permitting and zoning issues need to be streamlined and understood to allow these vehicles to be installed in the case of the infrastructure equipment and actually sold to the customer. And again, we really never want to lose sight of actually the safety concerns, especially with the fact that we've got new technology being used in new ways, new environments by the general public.
So if we put our business hat on, what are the types of business models that are being considered to monetize charging systems? And then if you'll go into that, I know we have that up on the slide, to make sure you drill down a little bit about some of the regulatory standards and how a change in a mindset is needed to occur actually as we speak.
So what we're starting to see is different sort of infrastructure business models regarding the actual charging of the vehicles themselves. Some companies may actually create free charging stations at their place of work to encourage their workers to buy this equipment. So you'll start to see free charging stations at the workplace. You're also going to start to see free charging stations at different public spaces such as movie theaters, restaurants, and businesses as a way for those establishments to encourage additional customers to come to them, especially those that are at the forefront of adopting this technology. And then, of course, there's going to be a public charging model, a pay-per-charge model that will either be a pay-as-you-go, or in some cases you may see a cell phone type of a subscription model where the consumer will pay on a monthly basis a flat fee or perhaps a per charge, and that'll get charged to their account as they go forward. What we're also starting to see then is a confluence of utilities, manufacturers, and regulators all coming together to solve some of the regulatory issues that currently are going on with the deployment of the vehicles and related equipment. And it's critical that all these different stakeholders come together now and in the next probably 18 to 36 months to iron out a lot of the outstanding issues and questions that are still out there in order for wider adoption to occur. And we really hope to try to play a role, whether it's through our standards that we currently have, revising new standards for the new technologies that we assume will be coming, as well as looking at some of the international standards and trying to see where you all can fit, not only with existing technologies, but new technologies such as inductive or wireless charging and vehicle-to-grid technology. And all these areas really kind of roll together into increasing that consumer confidence and changing the mindsets a little bit in terms of what folks today perceive as the benefits and perhaps the downside of electric vehicles. And what we're trying to really hone in on is, from a safety mission for UL, is that we want to make sure that the adoption and deployment of electric vehicles are safe, reliable, and that the components, whether they're on or off, are all working together correctly and safely in that kind of environment. And finally, it's to increase that consumer confidence is looking at what they perceive as benefits for savings, their increased choice and transparency, and corresponding to that environmental responsibility and energy independence that goes with the use of an electric vehicle.
Thanks, Chris. You know, I know we're going to be bringing Joe Bablow on in just a minute, and again, he's really going to focus on the key standards to help manufacturers get to market quickly. But I'd like you now, as we have on the slide, to tell us and tell the audience what UL is doing to support deployment of the EV infrastructure equipment market.
Absolutely, and you know, as I mentioned before, this isn't a discussion for the onboard systems, but you know, as that slide earlier showed, we do have standards that refer to many of the onboard components for electric vehicles. In terms of the infrastructure equipment, UL has written a recent standard that covers electric vehicle charging stations. We also have developed an electric utility smart meter standard, which at first blush wouldn't seem to be something that would be involved with electric vehicles, but we're starting to see customers actually embedding metering technology inside of those charging stations, whether it's for billing purposes through the utility or multi-residential units where they need to have separate billing mechanisms established. And again, we're really looking at some of these emerging technologies, vehicle-to-grid, wireless technologies, as further evidence of where we're trying to help drive some of this adoption and deployment. In addition, we always work on, look at it from an international standards standpoint, and we try to work with as many bodies as we can for those new standards that are being deployed and work with them on harmonization across the regions, because at the end of the day, what manufacturers are really looking for is for them to be able to have either a one-stop shop in case of global market access, or at least have a landscape that's even from a standard standpoint. And so we're working with the international standards bodies on that process. In addition, you know, our core safety really is safety testing and certification for both the on and off-board systems and components. And we're looking to see where we can help our customers through increased capacity, the development of regional fulfillment, and also looking to see what other additional programs we can develop to meet our customers' needs both on and off the vehicle.
So, you know, as we have up here, you know, there's other offerings besides certification testing. Spend a little time on where else UL can help with this emerging business, getting folks to market quicker.
Absolutely. One of the areas that we're really seeing a lot of interest in are training programs that are dedicated for both the design, installation, and inspection of electric vehicle infrastructure equipment. We're currently in the process of developing our first training module, which will focus on the installation of the equipment. That installation program will be an e-learning program that will allow an electrician to go ahead and online take a course and then pass an examination that shows that they have the skill set to go ahead and actually install that equipment. And it does a couple things for that electrician. At one, from a consumer standpoint, they can show the consumer that they've gone ahead and taken that extra step, that extra education that shows their commitment from a training standpoint and knowledge standpoint. And on the flip side, from an inspector standpoint, when they go ahead and come to the site and inspect the installation, they can know beforehand that that installer has actually gone ahead and taken that course, passed that examination. And all this information will be online for both consumers, installers, and inspectors to be able to view. After we complete the installer program, which we're anticipating to be completed by early to mid-November, we'll be going ahead and developing an e-learning course dedicated to the inspectors, looking at what they need to be able to see and do when they're going ahead and looking at this technology. For many of the inspectors, they've never seen or heard of this technology, so it's going to be a good program for them to go ahead and get trained, go ahead and learn as much as they can, so that when they come to the site, there's also that learning piece that they've been able to have. So if you couple that with the installer training and the inspector training, the goal really is to try to speed that deployment and development of the infrastructure equipment. Finally, we're going to be creating a designer e-learning program with a focus that needs to be considered of when the equipment's being installed. You know, there's things that go into it other than simply installing, and that could be things such as site selection. That could be selection in public or multi-residential charging environments, and everything that needs to go into that process, whether it's looking at the actual specific location of the actual equipment, to the number of pieces of equipment that's needed, to what other infrastructure needs need to be put in to support that deployment. So really, it's the idea that from a scratching standpoint, from the very beginning, what does someone need to do when they're looking to design and install this equipment?
You know, this is really exciting stuff, and we put this slide up here. I'd like you to talk to it, kind of give a back-of-the-envelope market potential for what you're seeing.
Yeah, absolutely. And what we're seeing is that in many cases, from a lot of the different analyst reports and anecdotal evidence from talking to the different municipalities and manufacturers, that there's really a broad estimate that there will need to be between 2 to 2.5 charging stations and fast chargers per vehicle. So if you estimate that by 2015 in the U.S. there will be approximately 1 million vehicles on the road, you do the math, that gives you about 2 to 2.5 million charging stations. With an average price, you get to about between a $4 to $6 billion market opportunity in the U.S. alone.
So let's kind of summarize some of the things that the audience can get by collaborating with UL, some of the things you can do to help them.
Absolutely. At UL, we really do understand the need for developing new and highly innovative products and being able to push those boundaries of both design and function. It's important that we meet your go-to-market dates, and we do everything we can on the front end to understand that and work with you on getting your product to market faster. In doing so, we also have a process by which we can reduce the risks for you when you go ahead and create your product. That looks at the different stages from the actual conception, prototyping, manufacturing, and installation, the full concept that goes from cradle to grave, so to speak, for your equipment. And we really have a good process that we think works for customers in terms of getting their markets through the process. And finally, what we're really focused on, too, is the fact that many of our customers are looking to sell their products not just within the U.S. market, but also looking to sell them globally. And so what we do is we do provide that one-stop shop offering where we can go ahead and test not only to our standards that we write, but also to the other international standards to be able to give you that global footprint that you really need.
Well, thank you, Chris. And we're going to have you back in just a bit after Joe's on for the Ask the Experts panel. But I can tell you that your talk has generated quite a bit of questions from the audience, and we're putting them in the queue. So we're going to get to them. But what I'd like to do now, folks, is ask you to help us gauge what your anticipation is for having your product sold into the marketplace. So if you'll take a look at your control panel, I just launched a poll. If you would be kind enough to just answer your anticipated time to go into market is 0 to 3 months, 3 to 6 months, 6 to 9 months, or 9 to 12 months, we'd really appreciate that. And we'll share those results with everybody once we get everybody to vote. So I'm looking at it right now, and it's quite interesting, Chris, to see where the audience is at. And I'm going to keep the polls open for just a moment, and we will then share the results. And I know that we're going to have, Joe, I'm going to have you get yourself ready to come up to the virtual podium and start your presentation. But let's just keep this poll open for about another 5 seconds, and then I'm going to go ahead and close the poll and share the results. And it looks like we're just about there. I think everybody who's going to vote has voted. So let me close this, and let's share the results. And as you should be able to see on your screen, 21% of you are looking at going to market in 0 to 3 months, 16% 3 to 6 months, 15% 6 to 9 months, and 48%, or about half of you, 9 months or more. Chris, I'd be curious to know, how does these numbers track with what your research has shown?
You know, it's probably very true in terms of what we're expecting from an overall deployment. I think what we're seeing is that there's certainly been an early entrant companies that are looking to sell into the market early. And I think what we're also seeing is some companies are waiting to see, is this market going to take off? Is it really a viable market? You know, we've had so many starts and stops with the deployment of electric vehicles going back the last 10 to 15 years. I think there's certainly a little bit of reticence out there of companies that want to get into this business, are looking to get in this business, but really are waiting and seeing whether or not this is going to be a real business or not. So I'm not surprised you're seeing kind of a number that's high in the beginning and then a number that's high in the end, and that does not surprise me. In fact, it's what I would expect.
Well, great. Thanks, Chris. So folks, for those of you that may have just joined us, we just heard from Chris Pauley, and Chris is the Smart Grid Integration Manager, and he spoke to us about some of the industry trends and the business opportunities around the booming EV infrastructure equipment market. Now, we're going to focus and shift to our next section, which is what you need to know about the 4 key standards that are critical to success for participating in these market opportunities. And to lead the webinar, this portion, I should say, is Joseph Bablow, PDE, and he's a real electric vehicle expert with UL. And at the end of the portion, we'll bring back Chris to start taking your questions along with Joe. But first, let me tell you a little bit about his background. He's been with UL for more than 14 years, and he currently holds the position of Primary Designated Engineer for Automotive Equipment and Associated Technologies. And his area of responsibility in this role includes the categories for EV chargers, EV supply equipment, and EV connectors and inlets. Now, before he had this role, he held the position of a Senior Project Engineer working in the IT and appliance categories within UL. And then prior to working for UL, he spent a year in the power utility industry working for a consulting firm in downtown Chicago, and he holds a bachelor's degree from Milwaukee School of Engineering. Joe, we're really excited to have you. Welcome to the webinar, and I'd like you to start off by telling the audience what you're going to cover, what you want them to take away from your portion, and I'll turn it over to you.
Okay, thanks, Mike. It's a pleasure to be here today. My part of today's discussion will center around the 4 standards that are used in evaluating electric vehicle infrastructure equipment. These standards cover the equipment itself and the components used with the equipment, which we'll explain a little later. Training seminars for these standards can take up to 3 to 4 days minimum to go through all of the information that is in a standard, and we don't have anything like that time today. So what we'll be doing is focusing on 2 specific areas and speaking to those areas from a high viewpoint. Those areas consider the scope of the document and the requirements that present the biggest challenges to manufacturers. So the hope for what you can take away from this today is some information on the areas that cause the most problem with delays, rework, redesign, or non-compliant issues where the product needs to be redesigned or reworked in order to be resubmitted to UL. On this slide, you can see the 4 standards we will discuss today: UL 62, UL 2202, UL 2251, and the new UL Subject 2594. We'll discuss each of these standards individually, focusing on the 2 areas I mentioned previously, with an eye on how you can get these innovative technologies to market more quickly. Before we start the discussion about the standards, it may be beneficial for us to discuss UL standards from the viewpoint of typical requirements and objectives. All UL listing and recognition categories use a specific set of requirements to address 3 main areas of safety. That includes fire hazards, electrical shock and energy hazards, and injury hazards. So I'll give a brief explanation of what these hazards are and how UL requirements are used to address them in general. For fire hazards, products are provided with an enclosure that serves a couple of different functions in relation to UL standards. It could be a mechanical enclosure, it can be an electrical enclosure, but in the case of fire hazards, what we call it is a fire enclosure, even if that term is not used within the standard. And the purpose of a fire enclosure is to keep a fire that develops within that product from spreading to the rest of the building and the surrounding area. So it's not going to protect the product, but it's going to protect the area where that product is used. So again, a fire enclosure is required to keep a fire inside and not allow it to propagate to outside other areas where other combustible materials may be located. The enclosure is required to keep flaming particles, flaming drops, burning insulation, molten metal, things of this nature within the enclosure until the fire either self-extinguishes or can be put out. Or for products that are movable or portable, in some standards, the product is considered capable of being moved away from its sitting location, its location where it's being used, and moved to another area where it is safer and combustible materials are not present. The concept is addressed in UL requirements by flammability requirements for non-metallic enclosures. If you have a non-metallic enclosure, you can have flammability requirements using flame ratings for non-metallic materials, which are starting with the most flammable, which is HB, to the least flammable, which is your 5VA and 5VB. Products that are large, bulky, and cannot be moved or bolted to the ground are typically, if they are provided with any type of enclosure that is non-metallic, will be required to have the higher flame rating or the least flammable material. And the reason for that is the material is not supposed to melt, start on fire, and continue to burn, or burn open such that flame can fall out of this onto other combustible materials. But if you have a smaller product, as I mentioned, other standards allow you to move the product away, throw it out the window, out the front door, take it outside. Those types of products may have a lower flame rating, maybe a V2 enclosure, because they expect those fires to be able to be moved away from the hazardous area. We also address fire enclosures through openings in the enclosure. Again, we don't want flaming particles or burning insulation to fall out of the product, so the openings, the requirements for openings are taken into account to make sure that anything that falls within the product and is burning will be kept inside the product, which can be handled through size of openings and location of openings. However, there's also requirements for baffles or louvers within your enclosure that can keep the opening requirements can be larger and placed differently if the products are deflected back in and maintained within the enclosure. Okay, so the next one is electric shock and energy hazards. And simply stated, the user cannot have access to an electrical shock hazard or an energy hazard. Energy hazards have maybe a low voltage, which is considered acceptable for contact, but high current levels can lead to electrical burns or more serious hazards. So when a user contacts parts, circuits, or output wires, they cannot be exposed to a shock or energy hazard. And the user must be protected by limiting the circuits or insulating them so that the hazard does not exist. A couple of examples: old desktop type computers that had printer cables running to the printer, or the cable to the mouse, the cable to the keyboard. All of these circuits are all limited power in a way such that the voltage was maintained at a low level even under fault conditions, and the current was limited even under fault conditions, so that an energy hazard did not exist and a shock hazard did not exist. Therefore, the insulation on the cable, or what was accessible to the user, is not a hazard. Also, you can look at the power cord that goes to any device that plugs into the wall. That is addressed through insulation requirements, so the more robust insulation will keep the user from being able to contact the live circuits. You can also use an enclosure, as I alluded to earlier when we said there was such a thing as an electrical enclosure. An electrical enclosure can be used to separate the user away from the hazardous part, and we will check that through openings in the enclosure using probes to try to contact the live parts, and placement, spacing of those circuits and components can be used to protect the user using enclosure requirements. The last one is injury hazards. And injury hazards are simply hazards to the user from sharp edges, pinch points, moving parts, gears, anything along those lines. If a user is required to do something with the product, whether it's lift the product and move it somewhere, open a door to access an inner area, or they're allowed to, are told to make an adjustment or turn some sort of handle. Whenever they're told to do something along those lines, if there's not specific instructions or handles for lifting or things of that nature, we have to assume that any unforeseen hazard in any manner in which the action may be accomplished is something that we need to look at. A few examples of that: lifting the product to move it from place to place. Again, if there's no handles, no lifting points, the user will be expected to grasp any area within that enclosure. And if there's any sharp edges or pinch points on that enclosure, the user will need to be protected or warned against them. If a user needs to open a door to replace a paper in a copy machine, again, if you have any kind of hazardous circuits or any areas, hot objects, copy machines have heaters in them. So if you have those areas that need, again, protect the user or guard them from that contact. There are exceptions, such as power tools, where you have a saw blade, and obviously the saw blade is needed to perform the intended function, and we expect the user to understand and know that that is a hazard, and it can be accessible to the user. So the general concepts that I just discussed are pretty much the backbone of UL safety requirements, and they may be addressed in a different manner or different levels of complexity depending on the type of the equipment, but overall that concept will stay the same. All four of the standards we discussed today will have the same concepts in common, so we will not discuss the specific requirements in each standard because, as I mentioned earlier, we don't have that sort of time. So our discussion today will focus on the two main areas I described earlier. The scope, which becomes a necessity because it's hard to design a product if you don't know which standard you're trying to design it to, and the requirements, which we will refer to as need-to-know items. That part of our discussion will focus on areas such as requirements which tend to be easily misinterpreted, long-term testing, and requirements that tend to cause the most delays. So let's begin our discussion, and we will discuss these two areas for the four standards displayed earlier.
Joe, it's Mike. Let's start by talking about which of these standards would be used to cover the overall infrastructure equipment opportunities.
Okay, Mike, that's a good question, and it's also a good place to start. Of our four standards, two of them apply to overall electric vehicle infrastructure equipment. That would be UL 2202 and UL Subject 2594. So we'll start with 2202. This is the American National Standards Institute, or ANSI standard, for electric vehicle charging system equipment, and we are currently on the second edition of this standard. The scope of the document is something that has been misinterpreted in some cases. It can be misleading when considering the differences between UL 2202 and UL Subject 2594. However, it's actually an easier definition if we try to explain it in this manner. The scope of UL 2202 covers electric vehicle chargers, which can be located either onboard or offboard the vehicle. And they can be defined in a couple of ways. A product that supplies power directly to an onboard battery, or a product that performs a voltage conversion, such as switching an AC input to a DC output to charge the onboard battery. Okay, that's the main key between the two standards, as UL Subject 2594 is a device that will require power to be transferred to an onboard charger. So there's actually a charger in between the 2594 product and the onboard battery. And that product that is between them is a UL 2202 charger. The scope also sets the input voltage limit at 600 volts AC. However, no output limits are specified. So UL 2202 does include what would be considered DC quick chargers. In the use of UL safety standards, we begin to see patterns where some problem areas seem to occur for manufacturers, or manufacturers' difficult time interpreting the requirement or how to comply with that requirement. These areas become a source of delay due to rework or retest of the product, or can slow down an evaluation because compliant parts or materials were not chosen by the manufacturer during the design phase. So today we'll address some of these areas in the hope that it will benefit manufacturers of these products and help alleviate some of these issues. If a material is chosen for a product and the material does not comply with these requirements in the standard, which is 2202 Section 4, the requirements say you have to comply with UL 746C, which is the UL standard for non-metallic enclosure materials and specifies flame ratings and mechanical properties. So again, if we don't comply with those material requirements, then the material may need to be changed. Okay, so if we have to change the material, all work with that enclosure has to be repeated and started from the beginning. And that's always a source of delay while new materials are found and new enclosures are produced. So a thorough understanding of the enclosure requirements will lead to the choice of material that will comply with UL 22 and 2202 even before we begin our evaluation. The second area that leads to delays is related to spacings. These are physical spacings on the board between different circuits, such as primary to secondary or primary to ground. And there's physical spacing requirements in the standard that say how far apart different traces on a printed wiring board need to be. If the printed wiring board trace layout is not designed with those spacings in mind, and we have to stop the evaluation to redesign the printed wiring board trace layout, that is another source of delay. The last issue we'll discuss for this standard is the area that typically involves the most hardship for manufacturers, and that's the issue of personnel protection equipment. Personnel protection equipment, which is covered under UL 2231, is required by the National Electrical Code in Article 625. These are required to be provided on all off-board products that supply power to an electric vehicle. The equipment is provided to protect the user by using different design components to make up a system of protection. Two different types exist. There's grounded systems and isolated systems, and that standard will tell you what needs to be included in each type of system in order to protect the user. If the product is provided with an automatic reset or an auto self-test, both of those types of devices require either a software evaluation or solid-state device evaluations under UL 1998 and UL 991, which are more drawn-out type of evaluations requiring EMC testing and long-duration testing. It should be noted that whatever protection system is chosen, it will involve some extensive testing along with EMC, as well as software and solid-state devices. Manufacturers should start the process of having the personal protection equipment evaluated as soon as possible in the development of the product, as non-compliant results in the evaluation typically require changes to components that affect other testing. When this happens, testing may need to be repeated, slowing down the evaluation. And the last point we want to make covers what we call certification information. And this is just a simple code that is used to define different categories. We call them category control numbers, or CCNs. And as shown on the slide, it's not shown on the slide, the particular CCN for this category is FFTG, and that's the product code you should submit under when submitting a charger to UL for listing.
So let's cover the second standard, that which I know is UL 2594, which is used to cover the overall infrastructure equipment. You mentioned that at the bit. I want to make sure that everybody gets that one.
Okay. I'd be happy to do that. As we just said, the second document is UL Subject 2594, which is the outline of investigation for electric vehicle supply equipment, and we're currently on the first edition of this outline. UL Subject 2594 covers electric vehicle supply equipment, and as I explained, that's equipment that provides power to a vehicle with an onboard battery charger. These products are all located off-board. There are no onboard components or products within UL 2594, but there are three different types of products that can be included in this standard. First are electric vehicle cord sets, which are essentially level 1 devices in accordance with SAE J1772, and they're intended to be plugged into any available wall outlets and then connected to the vehicle. Typically they're portable and travel with the vehicle. There's also electric vehicle power outlets, which are products that are located off-board infrastructure type equipment that can terminate in a receptacle, which is then used to power the EV through the use of an EV cord set, as we just mentioned. So we have an actual receptacle being placed into a public area, again considered level 1 device. And the third type is an electric vehicle charging station, which is a device that provides power to the vehicle through an integral EV cable and connector or similar means, and those can be considered level 1 or level 2 in accordance with SAE J1772. So the enclosure requirements follow the same general concept we discussed earlier. However, the outline references UL 50E for environmental enclosures, and UL 50E is the standard for electrical enclosures environmental considerations. And this looks at different areas such as dust and rain, corrosion, and UV exposure if you have a non-metallic enclosure. So the minimum environmental type that the standard looks for is a type 3R, which requires rain and ice exposure along with UV exposure if non-metallic. And the plastic materials used as the enclosure must be able to meet all enclosure material requirements before and after UV exposure. The easiest way to comply with this requirement is to choose a non-metallic material that has an F1 rating. That's a parentheses F1, end of parentheses, and it's included in the certification of plastic materials, some of them. So when you go to choose your plastic material for your enclosure, you can research that and see if an F1 rating has been given to that particular material. If so, it has been evaluated for water exposure and UV exposure. If not, we would need to evaluate that material in accordance with UL 2594. In addition, for EV cord sets, the portable device, there's typically a small enclosure that incorporates or encloses the personnel protection equipment and other circuitry in the middle of the cord set. As these devices are portable and can be left on the floor, they have to comply with a chemical exposure test. and that's not a long duration test, but it does involve 3 exposures. The first one is a 7-day exposure to the vapors of dilute sulfuric acid. There's a 40-hour immersion to ASTM IRM 903 oil, and a 40-hour immersion in ASTM Refus Fuel C. So there can be no cracking or deterioration of the material after those exposures, and there are no materials that would be exposed to those exposures as part of their certification. So all non-metallic enclosures within a power cord would need to, or within an EV cord set, would need to comply with this test. And that should be taken into account before submitting the product. Also, we have the same issues for spacings and personnel protection equipment. They also apply to these products, and they are just the same as described in 2202. So again, we're going to touch on the certification information, which is again the CCN for this product, which is on the screen and shows its FFWA.
So we have an overall infrastructure picture. What about standards that apply to components used with these products? Let's talk a little bit about that.
Okay, well, that's another good question. And there are two standards that fall and cover the components involved with this, which are cables and connectors, and that's UL 62 and UL 2251. UL 62 is a standard for flexible cords and cables, and we are currently on the 18th edition of the standard. The scope of the standard covers flexible cords and cables used in a variety of products, but it does also cover the different EV-type cables that are required by the National Electrical Code to be provided with electric vehicle supply equipment. That's the 6 different types, EV, EJV, EVE, etc., that are called in Article 625 of the code. So UL 62 can be used to evaluate these cables using requirements that are included in what we call a certification requirement decision, or a CRD, which is simply a document where we document requirements for a different or a newer type of technology while we're waiting to get it through the consensus process. So it is in the CRD awaiting consensus process to put it into UL 62, but they are still effective requirements. We can cover these, like I said, with the CRD, and that's not something that is a secret type of document. If you are a UL 62 standard subscriber, or you're an existing UL customer, you do have free access to those CRDs. Okay, now the need to know information for UL 62. There's a couple things. First, there's a 30-day test for essentially UV radiation. We want to make sure that the material that is chosen for that jacket on the cable will comply with the UV radiation 30-day test. Otherwise, if you have to switch materials, you're looking at another 30-day duration in order to comply. In addition to that, the jacket also has to go through a water resistance test, which is only a 14-day test. However, it's a higher degree of non-compliant results, so we need to find a material that is suitable for water resistance as well as UV resistance prior to submitting to UL. And as far as EV cables, the certification information for EV cables is CCN FFSO, and that's the CCN you would submit to when submitting a cable. The second standard covering components used with infrastructure equipment would be UL 2251, and this is the standard for plugs, receptacles, connectors, and inlets. We're currently on the first edition of this standard. The scope of this document has again been sort of confusing. We don't cover receptacles in the wall or plugs that will go into the wall. When we say plugs and receptacles, we are referring to a specific device. Essentially, an inlet is on board a vehicle. A connector connects in, a vehicle connector connects into that inlet. On the opposite side, the infrastructure side, you have the same type of devices, but they're called plugs and receptacles. So if your EV SE infrastructure equipment was provided with a receptacle, which is essentially the same as an inlet, we would plug a plug into that receptacle, and on the opposite end of the cable, the connector, which would go into the inlet on the vehicle. The products within this standard can be rated for up to 600 volt AC or DC and up to 800 amps. So if when we get into DC quick chargers again, this standard is now prepared to handle the DC connector. There's also a standardized configuration for J1772, which is covered by this standard, but it's good to know that UL 2251 also handles other configurations outside of the J1772. So the need-to-know items for UL 2251, again, we have non-metallic enclosures, and in this standard, the non-metallic materials have specific electrical and thermal properties, relative thermal index, comparative tracking index, etc. You can choose a material that is previously recognized and does comply with the electrical and thermal properties. However, if the material does not, when submitted, there are tests in the standard to address that. And that should be taken into account as well. So again, proper material selection would be helpful. Also, non-metallic material enclosures used on connectors have to go through an impact test, a crush test, and a vehicle drive-over test. So proper design of the enclosure to be able to withstand those tests in the standard is also needed. Impact test, of course, addresses dropping the connector. Crush is setting something down or stepping on the connector. And a vehicle drive-over is simply driving the vehicle over accidentally driving the vehicle over the connector. There's also one long-term test that's involved. It's a 50-day test that is called the Control Pilot Contact Resistance Test. There's 4 samples needed for the test and 2 exposures. The first one is carbon dioxide, sulfur dioxide, and air. And the second one is hydrogen sulfide, and air. So both of those have to be for 50 days, and at the end of the 50 days we measure contact resistance on the pin, and it can't be any higher than 10 milliohms. And this is another test that you should factor into how early you need to submit to UL in order to get your product covered. And finally, the certification information for this category is FFVI2. You'd submit to that CCN if you needed to submit a connector or inlet. Okay. The last slide I have real quick is we made reference to ANSI earlier, so I just wanted to throw this out there. An STP, Standards Technical Panel, is something that we put together, and that's how we deliver our consensus process in developing our standards. Right now, there are 2, UL Subject 2594 and UL 2251 are in the process of developing their STP. So if anyone in the audience is interested, please let us know, and we'll be happy to answer your questions about STPs.
Hey, thanks a lot, Joe. We have a ton of questions in here, and I'm going to ask Chris to come back to just kind of wrap up on some of the ways of working with UL, and then we're going to do one quick poll and start to dive into a lot of great questions. So Chris, if you don't mind stepping back and just kind of giving the summary on this slide here.
Sure, absolutely. Just kind of to wrap up, we've gone through a lot of information in terms of market as well as some of the standards and really where UL plays a role. And what we're trying to really push in terms of where we can help is that we really want to make sure that you understand that getting your product to market is really of our utmost importance. And we will utilize our knowledge base and technical expertise to get your product to market. We're able to do that not only in the U.S. but also globally. And it really allows for that mark or UL mark on your product to add as a product differentiation. As well as by having access to folks like Joe and others that are really experts in the category. And they really give you that reliable, in-depth, and up-to-date information on the standards and the code developments that are currently going on. And really we're also looking at developing those other programs regarding training, e-learning, as well as some hands-on type training as well. And then, really giving, the best market acceptance to both the consumer and the inspector community as possible.
Thanks. Now, folks, as I mentioned at the top of the webinar, this has been a special edition that we are extending for another 15 or 20 minutes to take as many of your questions as possible. So here's where you can get some additional resources. No worries if you can't write it all down. We'll get it to you in an email. But, for technical questions, you want to contact Joe, and to get started, contact Chris at the number up there. And then if I could ask Joe and Chris to unmute themselves and step up. We're going to get going with some questions, but folks, we'd like to ask for one more poll to be taken. This will just take another moment. And which of these training programs would you be most interested in? And just choose all that apply, and we'll make sure you get information on it. And as you're doing that, I'm going to start to get these questions in the queue. I can't believe how many questions we have here. So we're going to get with them in just a second. I'm going to keep the poll open just a moment, and very interesting to see what the results are coming back. And we really do appreciate everybody's time and attention today. This is a very in-depth webinar with a lot of terrific information, and we really appreciate you sticking around. So I'm going to go ahead now and keep the poll open for about another 5 seconds, and if you just tell us which of these programs you'd be interested in, we'll get you the information on it. And I'm now going to close the poll right now, and let's share the results. And it looks like most of you are interested in the designer program, followed by the installer program and the inspection program. Terrific. Thank you for that. So, those of you that had sent in questions, I have a question here for you, Chris. When will the installer training program be launched?
As I indicated before, and this is a good kind of a wrap-up and come back to it, is we're anticipating by early to mid-November to have that program developed. And what we're planning on doing is we'll go ahead, and to everyone who's certainly signed up for this webinar, we'll go ahead and send out an email to them letting them know that this program's been launched. And I'm pretty confident we'll also put out a press release as well. And all of that, whether email or press release, that'll indicate where to go to sign up for the course.
Great. Here's a question from Troy. There was an announcement about a watt station charger for the home with 4 to 8 hour charging time, and estimated price is $1,000 to $1,500. The question is this a new product release, low volume situation with a high price tag? And the last part of it is, should we expect something closer to $300 to $500, including new 240 outlets, 240 volt outlets installations as the volume rises? And if you need me to repeat any part of that, Chris, just let me know.
No, I'm fine. In terms of company-specific technology, we won't really comment on that. But in terms of actual equipment that's being put in the marketplace, what you're probably going to see is that, like any other emerging technology, as volumes increase, costs will come down. So we're estimating an overall price right now between the fast charging equipment, which is certainly a significantly higher, those level 2, level 3 DC charging equipment versus your level 2, level 1 AC charging stations, to be around $2,000 for probably the next 3 to 5 years. Again, as volumes increase, as production increases, as costs come down, we anticipate that going forward those costs will drive lower as volumes increase, as competition heats up, like any other industry.
Here's another one from Ramesh. I hope I pronounced it right. How many manufacturers are making different EVs, and how would that split between existing manufacturers and independent manufacturers?
So it's as I started before, kind of the very beginning of our discussions. It's a very interesting technology and very interesting industry that's evolving, where you're really seeing confluence of very large traditional industrial manufacturers as well as automobile suppliers creating this type of equipment. Then you're seeing very large consumer electronic manufacturers entering the space, and then you're seeing a number of emerging and startup businesses. So right now, I think it's kind of a little bit of an open space right now, and everyone's trying to determine what role they're going to play. Are they going to play be seen as more of a niche provider versus an all-in-one type of environment, where you may see some folks focusing on the level 3 charging for DC off-board charging, or those that are looking to go after the in-home level 2 charging station market, and others that may look at more of the public spaces. So I think a lot of these companies are sort of determining where they're going to fit in the whole scheme of things. It's very early on, and I think from that poll that was indicated before, we've seen entrants come in, but I anticipate we're going to see a lot more folks come in later on as this market starts to grow and people realize that this is a real market and a real business going forward.
Thanks, Chris. I think that's a good segue to the next question for Joe, and this is from Andrej. Any plans to allow for charging stations at private homes? Let you take that, Joe.
From what we've seen, there are charging stations that will be at the home. Actually, some auto manufacturers have already been talking about including the charger with the sale of the vehicle, and it will send an installer over to install this charge station inside the garage of the vehicle owner. So that is something that is possible.
Okay. Here's one from Nick. how does the pay service charge per work at some sort of retail locations? Can you talk a little bit about that process?
Sure, and I think right now that's still an evolving model where you've got some, say, big box retailers, for instance, that may use charging stations as a loss leader but allow for their customers to park closer to the store and really try to capitalize on these emerging technologies and trends to show their leadership in this space. You may see other providers, say, parking lots that may use charge per fee models. You may see other storefronts that give away the services for free. If you go into the per pay model, again, you may see a one-time charge where you simply swipe your credit card. There may be instances where you'll be utilizing a network of charging stations. So we're starting to see companies that are developing those networks, and they're partnering with other providers to grow their network space. So that way, when you go ahead and utilize one charging station versus another, you're not necessarily paying out-of-network fees or things that are akin to more of the cell phone model where you pay roaming charges or things like that. So it's an interesting model. You're also seeing in some states that have utilities that are deregulated, you may see actually utilities stepping in and owning those charging stations and actually using them as an increased revenue source for them in addition to what they traditionally charge to customers.
Thanks. Here's a question from John. Is a fast charger a type 2 or type 3?
Well, it kind of depends on what you're calling fast.
Okay.
The UL documents don't specifically address charge rate or how fast something can charge. We're looking at the safety requirements of that. So the UL documents won't be concerned with whether or not something's called quick charger or fast charger. But essentially, if we look at DC quick charging, that's considered DC level 3 or DC level 2, which are new designations that SAE is looking into putting out there for the DC side. So you'll have AC level 1, AC level 2, AC level 3, and you'll have DC level 1, 2, and 3 as well. All
right. And here's a question. Are the inspector, electrician, and designer programs separate? And the second part is there a cost to take the training?
So we're looking at developing 3 separate programs, and that installer piece, as I mentioned before, is really the first program that's going to be launched with an examination, and we anticipate there will be a cost associated with that installer program. The second piece will be the inspector program, and we do not anticipate there being a cost with that program. So that really is open for the various inspectors or other authorities having jurisdiction to take the course, to really become educated. It really falls within our safety mission of providing as much information about products out into the marketplace and into the hands of those that most need it, which are going to be those inspectors and authorities having jurisdiction, being able to take that course. And then finally, from a design standpoint, that program will be sometime in Q1 of 2011, and yeah, we would also anticipate there being a cost associated with that program as well.
All right, and here's a question from Al. Have you developed a schedule and locations for the training programs, or will this be entirely e-training online?
You know, it's right now we're anticipating a rollout of e-learning. We also will anticipate developing an actual training program where folks will actually be able to demonstrate their capabilities from a hands-on standpoint. UL has a number of offices within the U.S. that we potentially could be using as training centers for this type of equipment. So you could conceivably go to a UL location and take these training courses to be able to meet those needs. And also for those companies that are interested, we can also develop company-specific training programs around their products. So if you have a specific product that has specific installation guidelines or things that are specific in terms of from a user standpoint that you want to have your dedicated installers trained on, we'll be able to go ahead and develop those types of curriculum programs to fit the needs of your specific technology.
Okay, this is a question from Ray. How can I be notified about the installation and inspector training?
So, you know, again, we're going to be anticipating sending out communication to everyone on the development of the different programs we want to be cognizant of the fact that we don't want to inundate you guys with spam emails, so to speak, or blast emails. One other way to check is we also have on ul.com/electric vehicle. That will really be our repository of information and updates on the different programs, standards that we're going to be launching. So I would say to go ahead and check out that site on a periodic basis, look for the programs. What you should see is when those programs get launched, there'll be a way for you to go ahead and click on that program, and that'll take you to our UL University portal, where you'll be able to go ahead and take those programs and actually take the examination for the installer program.
Great. Joe, here's one for you from Thomas. Is UL Subject 2594 available, and if so, how can we obtain a copy?
Okay. UL 2594 is available. It's a published document that is an active set of requirements, and it is available through our standards library. You can go to, it's www.comm2000, so COM 2000. You can go to that website and purchase UL standards from there. If you are an existing UL customer, so you already have inactive certification with us, then you are allowed to access all UL standards free of charge, and then you'd be able to access that one as well.
Okay. As long as you're up, here's another one. Would you give a short list of standards that apply to onboard equipment for EVs?
Yeah, we can go through that. We've got standards for electric motors, which is UL 1004. There's a standard for onboard inverters, which is UL 458A. Let me see what else we got. We have one for cables, which is UL 2733. And I believe there's one that's in development now for DC connectors, onboard connectors for onboard a vehicle, so connecting at different points, different equipment within the vehicle, which is UL 2734. And of course, UL 2202, which we discussed today, also covers onboard chargers.
Great, great. Well, let's see. We have a lot of questions here, and folks, as we said, we're thrilled with the amount of questions, and we absolutely promise to get back to everyone who asked a question if we weren't able to answer it on air. But Chris, here's something. Somebody wants information on when it's best to contact UL to get started with our product or their product certification. And Chris, let me take you off mute. Hold on. Sorry, go ahead.
Thanks, Mike. Yeah, that's a great question, and I think that's something that we really have been emphasizing with our customers. If you look at that list of when folks are looking to have their products go to market, you've got that first batch within the 0 to 3 months, and that latter batch of 9 months or more. And so I would encourage those folks that are looking to get their products to market within that tight window to come to us now, to reach out to us, start that process, start working with us today. And even though those folks that may be looking to go ahead and introduce their products 9 months or more, it's really the best way to start is early with us, even if it's simply an open discussion, talking about your product, talking about the technology, the standards, and even if you're not necessarily ready to go to market within the next 9 months or so, it's great to start those conversations with us. We can become more familiarized with your product, and then when you start getting closer to that prototype and ready for us to do that preliminary evaluation, we're that much more educated on your product and your geographical needs in terms of where you want to sell the product.
Here's kind of a sister question to what we just asked. Will you be conducting a similar webinar for international standards?
Very good question. We're actually looking to develop a similar type of format for international standards sometime the beginning of next year. A lot of those standards that are out right now are really still in that development stage. We're working with the different international committees to see where those standards are, what needs to be developed and fleshed out before they'll become those full international standards that you would see here for our standards. So that's why we're looking to wait a little bit until Q1 of 2011 before we'd have a similar type of webinar.
And finally for you, Chris, this is from Paul. Do you see any consolidation between the worldwide market adopting a single recharge connector?
That's a really interesting question from a technology standpoint, because what we're starting to see is that in the U.S. you have the J1772 connector. In Japan you have the CHAdeMO connector. In Europe they're looking to have some other sort of connector, and China may have a fourth. And so there may either be a situation where that's okay, and the automotive manufacturers will have to adapt their products to have those 4 different connectors, or you may see in the next 3 to 5 years a movement towards a single interface for connectors. I think the jury's still out on how that's going to happen and where the market's going to go. You could see some consolidation, and you may not.
Interesting. Well, I want to thank you, Chris and Joe, and of course our sponsor UL for making today possible, and all of those in the audience that attended and were interested enough to stay for the extended Ask the Experts section. We're actually at that top, and we just wanted to make sure that you knew our appreciation and you found today a value. And as I said, you will be receiving a short survey just a moment, and we'd sure love to get your feedback on how today met your expectations and what else you'd like to learn. And again, those questions that weren't answered, Joe and Chris will be very busy for the next couple of days responding. There's a lot of questions here, and we can affirm that will happen, and that there will also be an email going out to you next week with some follow-up information you saw here, as well as a link for how you can have an on-demand viewing for yourself or sharing it with a colleague. And we'd really like to thank everybody and wish you a terrific rest of the week. And as your moderator, this is Mike Agron thanking you, and bye for now.